So we just watched the AP Daily video, and I really like those visuals that she was able to provide us showing vertical displacement as we went around the circle. So you guys should have everything I have here down, right? The extra things I want you to add is the quadrantial angles. These are going to be very important for us as we start graphing and sketching the sine function. So there are 5 points, really 4 because they start repeating here. 0, 0, very important. Pi over 2, 1, very important. Pi, 0, very important. 3 pi over 2, -1, very important. And back at the beginning, 2 pi, 0, which is a repeat of 0, 0, because that's the period of this function. Some things I want you to also notice as you're looking at this is the basic shape of sine. When we start to graph the basic shape of sine, we need to know these 5 points because we need to be able to sketch the entire curve for at least one period of this function. So what I want you to notice, and what we're going to write down underneath the takeaways, I guess we could write it. Nah, let's write it underneath the takeaways. There's a little bit of room right here. When we are looking at the shape of sine, sine always starts at a midline, and I'm going to define what that means in a little bit, but midline, what do you think that means?
In the middle.
In the middle, great. Then it immediately increases, then decreases, then increases, etc., etc., etc. That will help me know the basic shape of the sine function. Starting at 0, 0, it should be on the midline. For most basic sine functions that we'll deal with today, that might be a lie, it's 0, 0, starting at the origin. But either way, when we start graphing it, we should start in the middle, increase, then decrease, then increase, and on and on and on amongst those 4 points. I think Corey's going to go. Did you go?
They can go.
Go ahead, Rosie. Off of the second video, off of AP Classroom, we see that there are, again, 5, really 4, because this one is a repeat. It's starting the pattern over. Main coordinate points we need to recognize for cosine. The main idea here, I guess comparing the two, I made a big deal about where sine started on the other side of this page. What's the difference between where sine and cosine start? Sine started where? At the middle. It was at 0, 0. Where does cosine start? At the top. So what we're going to tell ourselves as like just a helpful pattern for ourselves is that cosine starts at, instead of saying the top, we're going to call it the maximum. But yes, the top. And then what happens right after? Does it start increasing or decreasing after that maximum? Decreasing. But then since it's periodic, it will start to increase again and then decrease again over and over again as we keep drawing multiple periods of the cosine function. Now again, getting this concept of how they're related but different is very confusing. So as we start to look at sine and cosine at the same time, we need to be able to understand how they're changing in the different quadrants. And this all goes back to the all-star trig class that I want you to have memorized so you know the signs of these different trig functions, where it's positive and where it's negative. So in quadrant 1, which is between 0 and pi over 2, as theta increases, the sine function will what? Is our vertical displacement going to increase or decrease? Increase. So sine function will increase. But what will happen with the cosine function? Decrease, because we started all the way out here with horizontal displacement and we're getting closer and closer and closer in to that y-axis. So my cosine function is going to decrease. While they're increasing and decreasing, they're both positive. Then we get into quadrant 2, which is from pi over 2 to pi. So pi over 2 to pi. And as we keep increasing theta, what's going to happen to the vertical displacement as I come around here? Is it increasing or decreasing? Decreasing, because I would be coming down towards the x-axis. So the sine function will decrease But what will happen with the cosine function? Sorry, I just didn't hear you. Decrease, because we're still getting further away to a smaller value away from the y-axis. This is why this is now negative, because we've decreased to 0 and kept decreasing themselves. Cosine is now negative. What happens in quadrant 3 from pi to 3 pi over 2? Let's do sine first. What is my vertical displacement going to be doing? It looks like it's getting further away, but it's getting further away negatively, which means that it is decreasing, which is weird. It's getting smaller. The number itself is getting closer to -1, which means it's getting smaller. What's happening with my horizontal displacement in this quadrant? It's increasing. They're both negative in this quadrant because this is the t quadrant. That's where tangent is positive. But one is decreasing and one is increasing. Let's talk about quadrant 4, which is from 3 pi over 2 to 2 pi. What's happening with my vertical displacement? Increasing because it's going upwards. We're getting closer to 0 from being more negative. So that's when we are increasing. And what's happening with cosine? What's my vertical displacement doing? Increasing. I just realized I didn't write these words this whole time. So what I want us to recognize is that there are sections of these graphs, quadrants, different intervals of x values or theta values, where the functions are behaving the same or they are behaving different. And so we're going to need to start being able to recognize these different sections. We're starting at the very beginning, though, because we need to talk about the different characteristics that are involved with trig functions graphs, with sine and cosine function graphs. Which means I need to introduce to you a lot of vocabulary. We've officially started 3.5, so we're doing 2 lessons today, actually. They go right hand in hand. In section 3.5, we start to define the different ways we can manipulate sine and cosine functions to make them look more than just the basic parent function. When I'm talking about any sine or cosine function, they are called sinusoidal functions. Say that word, sinusoidal. Sounds like the name of a dinosaur, but it is not. It is a sinusoidal function. Any function that involves additive and multiplicative transformations of sine and or cosine. They're both sinusoidal functions because they are transformations of each other that we will get to in just a little bit. What I want you to highlight, and I recommend using my exact highlighting here because I will use the same color code the whole time. In purple, we're going to highlight the word midline in purple. You guys got this earlier. I asked you what do you think midline means, and you said the middle. Nailed it. Midline is halfway between the maximum and minimum values. I also teach dual credit of this class, and my textbook in that class has called it displacement. So if you hear me accidentally slipping into that vocabulary, I'm so sorry. Midline and displacement mean the same thing.
What is a dual credit for y'all?
It's trig, but dual credit trig. So displacement, which is how far it's displaced off of the origin, or where is the middle of the graph, how much has it been displaced? That's why that word works. With your pink highlighter, we're going to highlight the word amplitude. The amplitude of a graph is the distance from the midline to the maximum or the minimum. It's how high is the highest, and how low is the troughs. So crests and troughs. When is the only time you probably heard the word amplitude used? Music. You know how music is heard? Sound waves. You know what my function is doing? Waving. Oh, what? Amputate. Oh, amplitude. Grab your blue highlighter, and we're going to highlight the word period. We defined this word already in this section, in this unit. It's the length of the input values that it takes for the function to complete one cycle. The next word is called the frequency. We're not highlighting this one anything. The frequency is how many cycles occur in a set particular input value, usually 2 pi. It is the reciprocal of the period. What does reciprocal mean?
The opposite.
Tell me more.
In
Yes, but let's get it precise with math. Let's say I have the fraction 3 over 2. What is the reciprocal? We're just flipping the fraction over.
2 over 3?
Yes. So reciprocal is a flipped fraction. Technically, mathematically, those are different things, but I know why you said that. So yes to what you're thinking, but no mathematically. Then we can also talk about the concavity of this function. Since sinusoidal functions oscillate or go back and forth between concave up and concave down over the whole domain, we may be able to talk about specific sections of it, but not in general, whether it's concave up or concave down. The last way we will define sinusoidal functions is whether they are even or odd functions. I'm not talking about even numbers, odd numbers. I'm talking about even and odd functions. Even functions have reflective symmetry over the y-axis, which means I should be able to fold this graph on the y-axis and have one side land directly on the other. That's an even function. Odd functions have rotational symmetry about the origin. So odd origin, that's how we're going to remember that. When we do this, that means we would put a pin in the origin, like tack it down at the origin and spin it around to see if one side lands right on top of the other when we spin it. And before we start really transforming these graphs, let's see if we understand how to identify these different things for just the basic sine function. This is the sine function you guys wrote from the other section of notes. We have from 0, 0, it increases, it decreases, it decreases, it increases. That's the vertical displacement around the unit circle. My first question for you is, what is the midline? Meaning, what is the middle? 0. When we write midline for me, I'm always going to have us put D equal to whatever that number is, and that will make a lot of sense in a couple days when you see why I'm using the letter D. In my mind, D is for displacement. Because we're talking about where the center line for this graph is. This is the middle. This is the midline. The amplitude we define to be the height of the trough or the height of the crest. So how far it is to go from the midline to the max or the midline to the min. How far is that on this one? 1. So no matter where I look, if it's a crest or a trough, my amplitude, A, is equal to 1. We know this one because we've seen it a few times. What is the period of this function? How long does it take for us to go from here to its next starting point? 2 pi. So the period is 2 pi. This does, is it your birthday? Yeah. Happy birthday. We'll sing to you later. Don't worry, we'll sing to you later. Now frequency, remember, we're not going to freak out about frequency. All it is the reciprocal of the period. So how do you flip over the number 2 pi?
Pi 2. Pi over 2.
Pi over square root 2. Square root pi over 2. Square root 2.
Wait. Okay, we're thinking way too hard. Like I told you, we're not going to panic. This is a fraction. What number is underneath it?
1.
So let's flip it over.
1 over 2.
1 over 2 pi. Which means we have one cycle per 2 pi time. One cycle per 2 pi time. Every time we go 2 pi's, we'll have one cycle. That's what frequency is telling me. Now this is hard to do, and I know that you can't do this because your paper will literally just run out of space. But if I were to continue this function going off the page this way, oof, that was a bad job. Let me try again. That's better. We need to be able to see if we can fold on the y-axis. That's pretty easy. Can we fold on the y-axis and make one side look like the other? Like, oh, but like it's flipped around, right? So it's not even. It has to perfectly fold on top of each other to be an even function. But if I put a pin in the origin right here and then I rotated this around this way, would one side land on the other? Yes, that means that this is an odd function. So what we're going to do, well, there's nothing to do. We're going to say this is odd. Sine is an odd function. It goes through the origin. It can be symmetrical with rotational symmetry. Let's answer the same questions about cosine. Here's our cosine function. It starts at a maximum, decreases, increases, then would decrease again if we had more. What is the midline?
0.
Still 0. Okay, great. So how do I answer this one?
D equals 0.
Thank you so much. D equal to 0. What is the amplitude?
Well, 1.
1. So the distance from the midline to a max or the midline to a minimum, to a crest or to a trough, for any of these is 1. So we would say,
equals 1.
very good, A equal to 1. What is the period of the cosine function?
2 pi.
That's how long it takes for us to go from the beginning point to the ending point, which means my period is 2 pi. Thus, the frequency is
1/2 pi.
1 over 2 pi, yes?
Oh.
And then here comes the weird one where we have to decide if it is even or odd. Again, this is tough because I know you can't extend the graph beyond the y-axis, but what if I go do that for you? If I extend this graph out, oof. Okay, pretend that looks nice. Can I fold this along the y-axis and make one side land on the other?
Yes.
Which means, is it even or odd?
Even.
Even, very good. Okay.
I missed the notes and I'm back.
And he's back. So that's really what we're going to be doing today, is making sure we can read these graphs when they get a little off-centered, if you will. Are you ready to try one?
Yes.
Here's not the basic trig function.
Whoa.
This one says 2 periods of the sinusoidal function f of theta are shown in the figure on the right. Find the period, frequency, amplitude, and midline for the graph. Don't overthink this question. What is the midline? We're going to start there.
0.
Ooh, I'm hearing 3 and I'm hearing 0. Midline, remember, is where the middle is. Where's the middle of all of these things? 3. So 3 is my midline.
Oh, I understand it now.
So I put D equal to 3 on midline. I like to start on the midline and the amplitude personally, because especially in multiple choice settings, you can usually eliminate stuff that way. And they're easy to see. What is the amplitude?
6.
It is 3. What? Indeed. Remember, the amplitude goes from the midline to the max, midline to the min.
Aye, aye, aye.
Remembering to go from the midline, what is the amplitude?
A equals 3.
A equals 3. Okay, now we'll go look at the period. So how long did it take for us to finish one cycle?
Slow your roll, partner.
Pi. If we're starting here, we need to know the next time we're at a midline that goes up. So we go boop, boop, boop. There we go, right? How far did that take?
Pi.
Pi. So the period of this function is from 0 to pi. So my period is pi, which makes the frequency what? 1 over pi.
Nice job, Shane.
Can I have you guys try one on your own?
Absolutely not.
On the back, example 2 is for you. Thank you so much for your honesty. You're going to do it, though.
Definitely missed
Number
my
2 is for you. I want you to try the exact same kind of question that we just had. You got it. Don't panic. So I drew in my midline, my displacement, if you will.
1.
It's 1. So we answer D equal to 1. What was the amplitude?
2.
2, because no matter where I look, the distance from the midline to the highest point or the lowest point would be 2. Now, the period is different this time. How long did it take for me to finish one full cycle? Pi over 2. Because if I go from maximum to maximum, that took pi over 2 radian to have that happen, which means my period is pi over 2. So the frequency is 2 over pi. There are 2 cycles every pi. There are 4 cycles every 2 pi.
So I was close.
You were close.
I doubted myself.
No, we don't.
Can I make it a little bit harder?
No.
Because what if I take away the picture and make you have to think about the picture? I'm going to do it. It says the sinusoidal function h of theta has a maximum at the point pi comma 8. The first minimum after reaching this maximum value occurs at the point 3 pi comma negative 2. Find the period, frequency, amplitude, and midline for the graph of h of theta. Okay, I don't know about you, but I feel like I need to see what this looks like. So I'm going to draw myself a little sketch. And I highly recommend always drawing a sketch of sine and cosine when you're using them. It told me that we'll let this be pi, and this will be 2 pi, and this will be 3 pi. Sure. It told me the first time I have a maximum is at pi, comma 8. And the first minimum after reaching this maximum value occurs at 3 pi, comma negative 2. I know that my graph is not balanced out. I'll get over it. It's fine. I know these two things, yes? If that's the first maximum, then I have a minimum. Where's the next maximum?
2 pi. No.
How long did it take for me to go to maximum to minimum?
3 pi.
2 pi, because 1 pi, 2 pi. So how much should it take for me to get to the next maximum?
5 pi.
Yeah, we should be at 5 pi because we need to jump 2 more times. So here's 4 pi and here's 5 pi. We should be back up at the top. The reason I want this information is because now I can answer all of the questions. Let's go with maybe what would be the easiest for you guys right now. What is the period of this function?
4 pi.
4 pi. How long did it take for me to go from maximum to maximum? We started at pi. We ended at 5 pi. So that was 4 pi's. That was my period, by the way. I'm doing this out of order from what we've been doing. Which means the frequency is what?
Pi over 4. Pi over 4. Pi, oh wait. 4 over pi.
1 over 4 pi. My friends, just flip it over. Put that in the denominator. So we have 1 period every 4 pi. Ooh, but then we have questions like midline and amplitude. Midline, you guys told me without like pausing that midline was the middle. What's in the middle between 8 and negative 2?
Negative 2? 3. 4.
So if we go 1, 2,
6.
3, 4, 5, 6, 7, 8, what would be in the middle of all of that?
5.
I don't know.
I know why you're saying that.
It's 3.
It would be 3 because there are 10 units separating them. From 8 to negative 2 is 10 units. So halfway between that would have to be the number 3. So we could draw in a displacement
Makes sense.
at 3. So my midline, D, is equal to 3.
Okay, amplitude is
Which then means what's the amplitude? 5. Because if we want to go from the midline, which was at 3, to our maximum at 8, or midline to our minimum at negative 2, again, my graph is not perfect. It doesn't have to be. I labeled everything.
Wait, did you not mean to put those points all the way to 8? Or am I tripping?
I did.
Yep, you lost me a long time ago.
Okay, let me back up to where I lost you. Where did I lose you? You said a long time ago. Did you get me putting the dot right here from the question and me putting the dot here from the question?
No, not that one.
And then do we know why I put this here? So it has to come back up. If it's a sinusoidal function, it has to go back and forth and back and forth. So if it took 2 pi to go from top to bottom, it's going to take 2 more pi to go from bottom to top. So I can put another dot right here. So the period, how long does it take for me to go to maximum? 4 pi. Now, the amplitude and midline require me to think about what's halfway in between the values of 8 and negative 2. And perhaps maybe it would be easier if I wrote these like evenly spaced. Here's negative 2, negative 1, here's 0, 1, 2, 3, 4, 5, 6, 7, 8. What's halfway between these two values? 3. That means that is my midline. And then if I was at 3, it takes 5 to get up to 8 and 5 to get to negative 2. Does that make sense?
Yeah, that makes sense.
Probably didn't help that my graph is super ugly, but
Yeah, I think that makes sense.
okay, well. Thank you for your honesty, I guess. Okay. Hey, guess what's back? Y'all remember this question?
No.
What's his name?
Yeah, Steve's making a comeback. Don't you wait. Steve's making a comeback from that classwork. Okay, this is not Steve's question. This is the broken clock question. We had this on topic 3.1, but we're going to revisit it because we can now answer more questions about this function. Let's remind ourselves how we read this thing and made some coordinate points and all that good business. It says the figure shows a large clock mounted to a vertical wall. The clock has an 8-inch long moving hand. Okay, so 8-inch long moving hand, which means this is 8. Oh, look at what color I just made that. What are you thinking that's going to be? Amplitude. We've just figured out that that's the amplitude. The center of the clock is 120 inches directly above the floor. Guess what color I'm going to use for that? It's purple. What does that mean 120 is for me? The midline. Whoa. At t equal to 0 minutes, the minute hand is pointed directly up at the 12, so this happens at 0. However, the clock is not working properly and the minute hand is moving twice as fast as it should. Thus, the next time the minute hand points directly up to the 12 is at time equal to 30 minutes. As the minute hand moves, the distance between the end point of the minute hand and the floor periodically decreases and increases. The periodic function h models the distance in inches between the end point of the minute hand and the floor as a function of time in minutes. We did this a long time ago, but let's see if we can still remember these coordinate points. Let's go first with our output values. What was my midline going to be again? 120. So that means for both of these coordinate points, I'm putting 120 as the output. And if we know that our amplitude is 8, now I can call it that, what will be the value of the outputs up here? 128. And what would be the value of the y coordinate down here? 112, because we're doing 8 below. So it's 8 above, 8 below. That's my amplitude. Now again, we said that at time 0, it's up above. So that means this is 0. And what's the next time that the minute hand would be up at the top? 30, which means when is it at the bottom? 15. And when is it in the middle the first time? Wait, how did we get 15?
Oh, 7.5.
Yes, 30 divided by 2 is 15. And if we want halfway between 0 and 15, it's just 15 divided by 2, which is 7.5.
Oh, wait.
And then what's halfway between 15 and 30? 22.5. My friends, just add these two numbers together. 15 and 7.5 is 22.5. We'll work on that. Okay, here's some things I want you to recognize that we can now name. We now can name the period being 30. We double check that our period is 30. We can name that our displacement or our midline is 120. We can now name that our amplitude is 8. Cool, which means we're able to answer questions like B. Find the period. What was the period? 30. Find the frequency. 1 over 30. Just flip the number over. What was the midline? And what is the amplitude? 8. Part C here is a bit of a turn from normal. It says find 2 intervals for which the graph of h is both decreasing and concave up. Show me with your hands, what does concave up look like? Great. Which one of those is decreasing?
G to J.
Yeah, from G to J, yes. So we're going to say that the first interval that we'll answer is from G to J, which is 7.5 to 15. But we also need another interval where this is happening.
Give me.
Because you guys told me this, right? It's nice because it's actually showing up here. We don't have numbers on it, but do you see another section of this periodic graph where this shape is happening? K and P? Is that the exact same shape? Okay, Keela's telling me to do this. Is this what you mean? I agree. This next section of the graph would be the next time that it's decreasing, that the graph is decreasing and the graph is concave up. Can we figure out what those numbers would be? What would be this time? A little bit more than that.
Oh,
Wait.
37.5.
37.5. You did 30 plus 7.5. Yes. What would be this time? 45. 15 plus 30 is 45. Or 37.5 plus 7.5. So our next interval where this happens is 37.5 and 45. And if I've asked you for a third one, you would draw another section of the graph, another period, and you'd find the next coordinate points where it was the same shape of the graph.
I'm straight.
I'm asking for too much. Okay.
I'm afraid it's already gone.
Any questions, comments, or concerns before we hop into homework time? Yes.
That's the final sentence we can write?
No, this one doesn't have the final sentence. Remember, the final question that you're thinking of asks you describe the graph of H and describe the concavity, or describe the rate of change in the concavity of the graph of H. Different question. I know it normally is there, so thank you for being prepared. It will be there later.